This is my latest force feedback direct drive racing steering wheel that you can build at home for just 150 euros. It provides a detailed force feedback of up to 15 Newton meters, and compared to my previous design, it is way stronger and reliable, replacing the main 3D printed structural components with metal ones. It is also cheaper, more refined, and simpler to build, thanks to the use of this off-the-shelf real steering wheel, which also gives it an improved look and a way better feeling in the hands. This new design is directly aimed at improving the issues you pointed out in the previous version, starting from the motor axle, which got hot in long driving sessions, causing the plastic clamp to soften up and the axle to spin inside of it. This never actually happened to me, but the issue is easy enough to solve by using this cheap aluminum clamp to hold the motor, which also makes the whole structure much stiffer. Another critical issue was the quick release table mount, which obviously can be only that rigid if made out of plastic. To solve that, I found this off-the-shelf quick release, which is usually used on heavy-duty camera tripods, and since it's made out of aluminum, it will be much stronger and reliable. Other design changes regards the pulley, which was slightly modified to better keep its concentricity with the motor axle. And obviously the two wheel halves were completely redesigned from the ground up to house a total of 8 programmable buttons and the wireless board controlling them, with also space for the needed batteries and the option of paddle shifters. These two wheel halves are exactly the components that need to be assembled first when building this wheel, starting from installing the 8 push buttons in the appropriate press-fit holes. Each button has a couple of terminals sticking out that will later be connected to the wireless control board, which gets mounted here. One pin of each button needs to go to ground, while the other one can be plugged on one of the signal pins on this row and will allow the board to read whether the button is pressed or not. The same can be done for the paddle shifter switches, connecting them in the exact way the other buttons are connected and inserting them in the respective slots, making sure that the small wheel on the lever faces outwards and the signal cable is connected to the normally open pin, so that the switch gets activated only when pressing the paddle. With the switches and buttons all connected, we can proceed mounting the paddles, which are the same as the older design and use 3mm nails to provide for a metal core that the magnet pressed here can attract, providing a super realistic feedback and satisfying sound. In the final iteration of this wheel, I actually ended up separating the magnet holders from the main structure, using 2 M3 bolts to screw them on. That is to provide for a flat surface that will nicely stick to the build plate when printing, allowing the use of minimal support structures and guaranteeing less warping, helping quite a bit especially when printing these components with more technical materials, even though I've printed everything out of PLA+. The two wheel halves are now completed and can be mounted securely around the 6.5 inches hoverboard motor, by inserting a 3mm nail as the lower pivot and tightening these 2 and 5 bolts. If the fit happens to be too tight and you can't properly insert them, like in my case, just loosen these bolts that keep the motor together and you will be good to go. This design is actually the only one I've seen that doesn't require you to modify the motor in any way. In fact, you can just disassemble it from the hoverboard, remove the tire, and that's it. This specific one I'm using has actually some holes drilled in it to help with cooling, but they are completely optional. Moving on with the build, to provide for a strong mounting point, the motor axle can be slotted inside this aluminum block, which also happens to have another 16mm hole positioned below it and rotated 90 degrees. This configuration is perfect to provide tilt adjustment. In fact, a 10 cm length of aluminum tubing can be slotted inside this second hole and mounted to the aluminum quick release plate, using this 3D printed component as a spacer to allow for the correct clearance and the best strength possible. This strength is guaranteed by using a single bolt on each side that runs straight through the quick release plate, through the spacer and through a hole I drilled in the aluminum tube, eliminating any flex caused by the previous base being 3D printed. The motor providing feedback is just one side of the story. In fact, it's completely useless if we can't precisely read the wheel rotation and adjust the feedback accordingly. For that, a rotary encoder is used and mounted to this 3D printed support that simply gets pressed here. The encoder is kept tightly in place using two zip ties and has a small pulley on its end that will later be connected to this bigger 3D printed pulley that I previously mounted to the motor housing, allowing the rotation to be precisely read by the encoder and transmitted to the PC. Exactly like in my previous version, the encoder has an idler mounted to it, which allows the belt to be tensioned by simply rotating the encoder inside its housing. Last thing before moving on to electronics is to mount the steering wheel itself. That is quite straightforward since it can simply be screwed on using 3 M6 screws and 3 respective nuts slotted here, here and here. The 3 holes that are needed to mount it aren't present from factory, but it's easy enough to drill them out, especially thanks to this 3D printed template that ensures alignment by slotting in the already existing holes. And with that, the wheel is sturdily mounted and we can move on completing the electronics. But before, I want to mention that if you don't have a 3D printed but want to build this wheel yourself, this video's sponsor, PCBway, is here to help you by providing a super high quality on-demand manufacturing service, which includes everything from the plastic 3D printing required in this project to CNC machining, PCB making, laser cutting and injection molding. If you're looking for a way to cheaply step up the quality of your creations, PCBway is definitely the way to go. They offer very competitive prices and fast turnaround times, so check them out at the link below. Back to the build, the last step remaining is to install the electronics, which is actually quite simple and consisting of just this maker-base X-Drive mini controller, which gets screwed here, paired to this break-in resistor that can be mounted above, and will take care of dissipating any excess energy that is generating when the wheel motor is resisting your movement. All the connections on the wheel and on the wheel base can be made following these circuit diagrams, which you'll find included with the download of the files. We can finish everything by simply connecting the needed 24 volts 20 amperes power supply and installing the 2 batteries that will power the wireless wheel buttons and shift paddles. And with that, the wheel is finished and feeling truly premium, making for a completely different driving experience, especially when compared to my previous version, mainly due to the increased rigidity and the better feeling of the real steering wheel in the hands. To properly test it, I've clamped it to my desk and slotted my sim racing cockpit below it, to provide for a sturdy seat, pedals and shifter. This setup allowed me to carefully test this new wheel exactly as if you were to build it, removing the advantages caused by having a dedicated cockpit. This wheel truly provides an experience you simply can't get anywhere else at this price, with a strong force feedback of up to 15 Nm, accurate input and a super detailed response, which is expected from a direct drive wheel. All of this can work thanks to the amazing firmware developed by FFBeast. In fact, I want to clarify that I'm not taking any credit in the firmware or even on the base idea of using a hoverboard motor as the wheelbase, since all of that was developed years ago by the previously mentioned FFBeast project, a link of which you can find below. Back to testing, the immediate difference I noticed was the overall stiffness of this new system. In fact, the aluminum quick release is rock solid, and paired with the aluminum clamp holding the motor axle makes for a truly rigid wheel that allows you to feel every subtle detail of the car behavior, and was basically indistinguishable from having the wheel mounted directly to my cockpit. One thing that we must consider is also price. In fact, for a total of between 150 and 200 euros, you'll be able to have an absolute beast of a wheel that directly rivals off-the-shelf models of double the price. It's also the only model I can think of where the quick release allows you to detach the whole wheelbase from the table, allowing you to rapidly remove it, eliminating the need of having a dedicated driving spot, since you can just use your desk and switch from an office to a driving setup in seconds. Modifying the setup slightly allows you to take advantage of the true potential of this wheel. In fact, mounting it to a cockpit and adding a VR headset brings the experience to a whole new level, with such immersion that you can truly get carried away and trick your brain into thinking that you are actually driving. The cockpit is the one that I've built in one of my previous videos, and it is fitted with my DIY pedals and DIY H-shifter, which build videos you can find in this playlist here. If you want to build this steering wheel yourself, you can find all the needed files available on Cools3D, a link of which you can find in the description below. I'm selling them for a price of just 20 euros, and with the purchase you will also find a guide with some useful build tips and instructions explaining how to install the firmware and set up the wheel. There will also be a detailed parts list with links to every component needed, down to every nut and bolt, and the needed circuit diagrams to allow you to easily build this project in the simplest way possible. A huge thanks goes to every single one of you that purchased the previous design of this wheel. Your support has truly been fundamental for this new project and for all the other sim racing related projects that I've brought to my channel. Also, thanks to PCBway for supporting this channel. That's it for this video, I will catch you in the next one!